Hey, what's up guys? So this is just going to be a quick short video on helping you solve linear inequalities. Alright, now like I said in the last video, inequalities equations very similar. Okay, so say we have an equation 3x minus 10 equals 2. We have the same equation but in equality form. It's going to be 3x minus 10 is greater than or equal to 2. Algebraically, the way we solve these is exactly the same. So if we want to get the 3x all by itself, we must first add 10. So you're going to get 3x equals 12. Again, add 10 because we just want to get this 3x by itself. Okay? So we have 3x equals 12. The inequality, 3x is greater than or equal to 12. So all we do is divide by 3, and we get x is equal to 4. Divide by 3, divide by 3, we get x is greater than or equal to 4. Solve them the exact same way, except our solutions are very different. Okay, the only answer that works for x in this equation is when x is equal to 4. But with our inequality, any number greater than or equal to 4 gives us a true solution. So, like I said in the last video, the only difference when you solve inequalities as opposed to solving equations is you must always graph your inequality on a number line. So we know that x can be greater than or equal to 4. Since 4 is our important number, we can have x equal to 4, so we're going to have a solid dot, or solid circle on the number 4. Now we need to ask ourselves, which is greater than 4? Is 5 or 3 greater? Well, I hope you all know that 5 is greater than 4, and if you plug it into your inequality, it's going to give you a true statement. So 5 is greater than or equal to 4. So we're going to shade to the right side where x, or every value that the blue is going to touch because it goes to positive infinity, is greater than 4. Therefore, that's why we're shading to the right. Get it? Good. All right. In a nutshell, that's all solving an inequality is. Now, there's some special things that come with inequalities. Let's see. All right. So, actually, this one's too similar to the last one we did. Let's say we do 1/2 x plus 5 is greater than or equal to 7. Alright, so we have negative 1/2 x plus 5 is, and I don't like greater than or equal to, let's change it to less than 7. Alright, so you have negative 1/2 x plus 5 is less than 7. Again, the way you solve these is the same way that you solve an equation. So the first thing you must do is get negative 1/2 x by itself. So we subtract 5 from both sides. So now we have negative 1/2 x is less than 2. All right. Now, this is where kids always get confused because this is one of the only differences between solving an inequality and solving an equation. Because if we're solving this, we want to get x all by itself. Okay. So in reality, we need to eliminate this negative 1/2. Now, there's different ways you can do this. And the easiest way is if we want to make a negative 1/2 become a positive 1, we want to cancel it out so we just have an x alone. We must multiply both sides by negative 2. Okay? Because negative 2 times negative 1/2 leaves us just with an x. And 2 times negative 2 leaves us with a negative 4. All right? The only difference is when you're solving an inequality, if you multiply both sides of the equation by a negative number, or you divide both sides by a negative number, you must flip your inequality symbol. The reason why you flip the inequality symbol is because you must keep the relationship true. And if you're multiplying both sides by a negative, you're kind of mathematically screwing around a little bit with your solution. So for inequalities, you just flip it. So if it was less than, when you multiply it by negative 2, it becomes greater than. So now we look at our number line. We have negative 4, negative 5 to the left, positive 3 to the right. Negative 3 to the right. And we have x is greater than negative 4. Since x can't equal 4, we must put a open circle on negative 4. And what number is greater than negative 4? Let's see. Negative 5 greater than negative 4. Is that true? No, that's false. I would rather be $4 poor than $5 poor. So since negative 5 is on the left side, but that's a false statement, we must shade to the opposite side. Or you could have seen right off the bat that negative 3 is greater than negative 4 because on the number line it's to the right. All right. The next problem We'll be up in a second. All right, so next example, we're getting on the way, and this one's going to be a little trickier. All right, so we're going to have x plus 6 is greater than or equal to negative 2 times 4x plus 12. All right, so again, we solve these just like we do equations. So what we must do is simplify both sides by distributing. So we have 3x plus 18 is greater than or equal to negative 8x minus 24. All right, now the next step, when you get, or not when you get, but when you need to solve an equation or inequality, you must get all of your variables to one side, all of your coefficients to the other. I'm going to move this 8 to the left by adding 8x to both sides. And I'm going to subtract this 18. Okay. Now, one of the tricks, or not one of the tricks, but one of the things that kids always fall into is that they, is that 42? They like to, what they would do here is, since in the last example we flipped the inequality symbol because we divided both sides by a negative, all right? Right here we flipped it. A lot of kids, what they do is they flip this inequality symbol because you subtracted a number from both sides. But you only flip the inequality symbol when you divide or multiply by a negative. And that's something you need to stay certain of. So here we divide both sides by 11, and you get x is greater than or equal to negative 42 over 11. All right. Now, a lot of you guys are going to ask me, how the heck are we going to graph this on a number line? Well, the same way you graph anything on a number line. First, you draw it. You put your important number in the middle. All right. Now, negative 42 over 11 is roughly, you just use my calculator, 3.82. Negative 3.82. So, to get a number smaller, choose negative 4. To make a number larger, I'll choose negative 3. All right. As long as you have a number that's less than on the left, greater than on the right, it's perfectly fine, because that's all a number line is. As we go left to right, it gets bigger. So we say x is greater than or equal to negative 42 elevenths. So since it can be equal to that, we must put a solid circle at negative 42 elevenths. We need to know which number is greater than that. Negative 3 is greater than, so we're going to shade to the right side. All right, and that's your answer. When you write your answers, make sure you give me the inequality written like this, and then also the solution on a number line. All right, last one. We're going to have 12x plus 10 is, I don't know, less than 37 plus 5 times x minus 5. All right, again, we must simplify this. The left side is simplified, the right side is not. So the first thing we're going to do, distribute the 5. So we have 12x plus 10 is less than 37 plus 5x minus 25. Now the next step is solving an equation, inequality, or whatever you must simplify both sides. The left side, again, is simplified, but on the right side we can combine 37 minus 25 to give us 12 plus 5x. All right, what I want to do is I want to get my x's to the right, my variables to the left. So I'm going to subtract, or my x's to the right, constants to the left. I'm going to subtract 12x from both sides. I'm going to subtract 12 from both sides. And we're going to get negative 2 is less than negative 7x. All right? Last step, divide both sides by a negative 7, since the negative 7 and the x are being multiplied. Okay? Since I divided by a negative number, we must flip our inequality symbol. So it becomes 2/7 is greater than x. All right? The only difference and tricky part here is that our equation, or our inequality has the variable on the right side. There's actually 3 things you can do. Okay? You can, well, first I'm just going to do this. 2/7, 0 is less than that, 1 is greater than that. Okay? There's 3 ways we can look at this. We can say 2/7 is greater than x. Okay? Or what I like to do is read it backwards. Always read from where your variable is. So we could read x is less than 2/7. Or you can just switch everything. So instead of x being on the right side, we'll make it on the left, which means 2/7 will be on the right side. But since you flipped everything, you basically mirrored it, you must also flip your inequality symbol. These two are equivalent inequalities, okay? Either way, it doesn't matter if you want to write all your answers with your variable on the left, be my guest, doesn't really matter. But the way we graph it on the number line is exactly the same. So since there's no equality here, we must have an open circle at 2/7. This says that 2/7 is greater than x. So that means that x has to be less than 2/7. 0 is less than 2/7, and you're going to shade to the left. Hope this video is helpful. Again, it's just quick examples, and I know I went really fast, but it's just to get how to solve inequalities. It's nothing crazy. It's really just solving equations with like 2 extra things. If you have questions, email me, check out the videos. Make sure you try some of the example problems so you can solidify your knowledge of solving inequalities.